put here various media types or things that I work on: images, sketches, videos, 3D modeling, and fabrication. And today, I'm not going to talk about all of them, but give you some examples, and more specifically about how AI can empower human. So I have some videos, therefore I need access to my computer, but hopefully this will be easier for now. So in general, I'm going to talk about maybe what is creativity in general, how computers or humans can be creative, and as Margarita said, how computers can empower human creativity. So when you think about computers, one thing, you can think of them actually as two different things. One is as tools, which is the view that I'm going to promote in my talk, and the other is maybe as some independent creative agents, right? So we're talking about artificial intelligence. We're thinking about independent beings that are artificial, and maybe they can also be creative. So I'm going to discuss a little bit about these two views. And I'm going to promote, in many cases, I'm going to show you how I believe the synergy between the man and machine is actually the way to go, at least for these types of tools that I'm going to show. And more specifically, I'm going to talk about image editing and maybe 3D modeling, building real furniture instead of just modeling them on computers, which is more like fabrication, and editing movies as well. So these are all tools that I created with many colleagues, both in my lab and around the world, actually, China and US and Europe. These are just examples of how I think creative tools should be or could be implemented using AI. So I'm sure that many of you heard in the past few weeks or so about these amazing developments, most of them from OpenAI. You've probably seen the DALI application, where someone can write a sentence and then basically you can create an image that shows this sentence. So if not, I suggest that you go and watch it. There's some very cool videos and some websites. And in those applications or those developments, what they usually promote is, I think, maybe something that AI can create anything that you can think of. But in fact, when you think about it, first of all, many times it fails, so it doesn't work all the time. So, and they're very picky about choosing the correct things. And also there's not much control for the human, right? So you can try a few things, but you don't really empower the human to do anything creative in this case. You just try a bunch of sentences and you can create various nice images. In fact, this development was supported by more previous development, which was more AI. And again, there are many articles about this. AI is mastering language. Should we trust it? And there are other articles about that. And these were talking about GPT-3, which is, again, a natural language processing development that seems like AI is becoming something that you can actually interact with and talk with and so on. And it actually can so it's great, it's amazing, it's nice, but I'm looking for something which would be a little bit more useful. So one thing you have to remember is that creativity is difficult, and obviously it's difficult for machines, as I've just shown you that these examples, you can create images, but you actually cannot actually fabricate these things or create real models of let's say, a machine that can create a car or a machine that can create something is wrong.
Yeah. Is the micro? They cannot hear the micro.
Yeah.
People at home are informing me, of all people, that they couldn't hear you.
So should I stand here? Now can they hear me?
And I think
maybe if you unmute yourself, I unmuted my computer, but if the microphone is connected to your computer.
Connected to my computer, it's connected to that computer.
No, on your micro. They say it's okay now.
Oh, it's okay now. Okay. Because I stand next to the mic. So I'm gonna be confined to this area, and we could move a little bit.
Yeah.
Anyway, so I started saying that's why I muted this because. So the view, in fact, is really how do we look at the AI? Is it really an agent by itself that can promote and create things, or it's rather a tool that can help humans, right? And the key question is how can we utilize machine learning and AI to help or to create tools that are in the middle ground, right? So humans can create everything manually, right? Or the computer can create everything automatically, right? As an agent. But I'm looking actually at the middle ground here, and that's why I call them intelligent tools, because they are tools. They are something that humans must interact with, but they are intelligent. They do have AI with it. So let's start with the first example. This is called semantic editing of images. I've been working on editing of images for many years, and but this specific example can also be seen as modeling of 3D objects and making it easier. Now, both things, editing of images and creating 3D objects, are extremely difficult for humans. And let me concentrate on the editing, right? So there are many, many tools to create 3D objects, but most of them look like this. They have a lot of menus and sliders and things, and you have to really master them in order to create a three-dimensional thing on a two-dimensional device, right? Because this is a two-dimensional device. So in fact, this is really more for the expert, right? And what if anyone wants to create a table or a chair or something which is 3D? This is what I was trying to do in my research. And so the idea was, I mean, again, something that we thought, how about if we just take a picture of something and then press a button and then you can create that thing. So this is in a sense the vision. It's still far away. We're getting close, but the idea is start with an image, because images basically capture these three-dimensional objects, and then you have appearance, you have more or less the structure, but you want to actually create a three-dimensional object with the human. So the human doesn't have to start from scratch. It does have some image, and even taking an image and converting it to a three-dimensional world is a difficult problem. Again, this has been studied for many years. And so the tool I'm going to show you is really taking the middle ground. It actually starts with an image and then uses a very simple a gesture from the human to create the parts of the object. And we call it 3-sweep, because basically you take the mouse and you use 3 sweeps of the mouse, 1, 2, 3, and it creates a three-dimensional thing. So here's an example. That's why I need to be here to press. Okay, so you see 1, 2, 3, and you get a three-dimensional object. So this is a simple box, but you can think of more complex objects. You see 1, 2, 3. That's why it's called 3-sweep. And it helps you at least capture something which is three-dimensional out of images. And you can also have more complex, like round objects, and even varying radius objects. So here, again, 1, 2, 3. So the first two basically create the profile of the object, and then the third one creates the sweep, and that's these types of objects are. So basically, as you can see, it's very simple to actually model something which is three-dimensional this way. The human needs to basically define the parts implicitly, because I'm going to show you in the middle how you can use that to create more complex objects when you have more parts. So not just a simple three-sweep. And basically, by doing that, the human defines the positions of the parts implicitly and uses the three-sweep. And behind the scene, what you have is the computer actually traces the image, traces the boundary of the object in the image, and basically can infer various things. So, but the key idea here is that the human doesn't need to be precise. It doesn't need to be very, tediously tracing the boundary and creating the three-dimensional thing and positioning them, because the computer works behind the scene to, first of all, guess what the profile of the part is, and the second thing, basically guess the relationships between the parts. So things that are almost aligned, the computer aligns them perfectly. Things that are almost perpendicular, it makes it perpendicular, and so on. And that helps basically. So first of all, you define the edges, and then it snaps whatever you sweep to those edges, and infer what we call geo-semantic constraints. So behind the scene of what you'll see in a minute are actually some optimization problem being solved while the person is actually editing. So, and here's an example of creating using three-sweep, something which is much more complex. You can see that it contains many, many parts, but I think you can understand the ease of use for the user. It basically sweeps those three things, and can also copy, change, and you can basically stay in a two-dimensional world. And this is why I call it image editing, because you're actually editing the image in a sense, but in fact, behind the scene, you have a three-dimensional object. So this can also be used to actually create three-dimensional objects. But in a sense, this still stays in the virtual world, right? So you create a three-dimensional object, and this object might have structure, it might have texture, which is the colors. But the thing is, if I remember what I wanted to press a button and actually create the object. So I want to actually fabricate, let's say, a chair or a table. So here's a virtual table, and there's an image of a real table. In a sense, they look similar, right? They have four legs, they have a tabletop, but there are some very distinct differences, and the differences are actually in the details. If you actually want to fabricate objects that are virtual, you cannot just download them from the internet. There are many, of course, furnitures and chairs and what have you, but in order to actually fabricate them, you need all the small details, which is exactly the screws and the hinges and everything, basically. So here's an example of a chest, and it has a drawer at the bottom and some doors at the top, something that you can find maybe next to your bed. How many parts do you think you need to create this specific object? Tell me.
24.
24.
500.
You're very close. So in fact, it needs 300 parts, more or less 300 parts to actually create this. When you think about, wow, what parts? So all the different screws and the hinges and the parts and the sliders and everything together makes this object. And obviously, if you create it virtually, you will only need 24 parts or something like that. So, but to actually create it, you need all these parts together. So we were trying to build a system where the user can actually model in the sense the 24 parts. So how will the actual object fit? And the computer would fill in all the details. And in order to do that, obviously, we need some information. We need some knowledge. I mean, the program needs knowledge to know how these things are actually fabricated. And also knowledge a little bit about physics, okay? Is it strong enough? How many screws I need, and so on and so forth. So the challenge is, first of all, to fill in all those many small details, to actually connect the parts. And here I had a wooden chest, but sometimes you have, you know, various materials, right? You have steel and wood and fabrics and so on, or glass, and you need to know how to connect all these parts together. So again, this is a real challenge, and at the end, we need it to be fabricable, meaning physics, material properties, and so on. So all this knowledge needs to be inserted into the program, so it'll be easier for the user to actually just fabricate very simply. So we call this work fabrication by example. And the idea is really we collect a bunch of fabricable designs, so actual designs of objects that could be fabricated by both designers and engineers. And we include them into a database, and using this database, we extract also various parametric representations of these objects. So when you think about what can change, maybe you want to make the table longer or shorter or higher, this affects the whole design, not just you know, a few things. And so we're inserting this into the intelligent model itself. And based on that, we're building a modeling tool that will be easier for the user to use. And we're talking about data-driven approaches, right? So machine learning, basically, how can the tool understand what's a real, or how to design a real object? You do it by finding examples. And in our case, the examples are based on what engineers actually fabricated or created. And again, using that, and again, I'm not going to go into the technical details, but basically we were applying many learning algorithms to those designs and learning from them to create the tool. So the idea here is really modeling by parts. And the key point is that any complex object, as you've seen before, is made out of small parts. And so when you design these complex objects, you can design them by creating those small parts. And since you are not, in general, an engineer, you can't really design the parts, but you can use other parts from other designs and sort of build them together to create more complex objects. So, as I told you, it's not, you know, the designs that we were actually basing our tool on are fully functional designs of objects made by engineers. And then we were extracting some semantic constraints on them, very similar to what we did in the previous application, but here it's really engineering constraints. And then we were building what we call parametric models. So here you can see an example of a model where you can change some parameters and you can see that the relationship between the different things. So you enlarge the compartment, the door goes along with it. You enlarge the length, you add more you know, stages to the ladder, and so on and so forth. So this is just one way of using the parametric representation. Another thing is if you enlarge the whole thing, you have to add more screws to hold the shelves. And so these are some examples that you can take an existing model and play with it. But the idea is really to model these by parts. So let me, well, okay, so this I talked about. The second thing I wanted to show you is really that when you model only based on the large part, what happens behind the scene is that the computer adds the connectors automatically. So it can know whether this is wood or this is plastic or this is glass, and also it can position it correctly so that you would add those you know, connectors. And in a sense, all the user has to do is really design the general thing, and all the details are inserted by the machine, and all the tedious handling of those things is handled by the tool. So here's a full session of modeling something. Let's see if it works. Yeah. So basically, you start by dragging parts from a library of parts, and when you position them, again, they sort of snap into place based on the model itself. So again, you don't have to tediously position them and make everything parallel and perpendicular and so on. And once you finish, you get all the parts that you need. You can go to the shop, buy the material, and in fact fabricate the thing, and it's sturdy, it stands, and everything is fine. You can use it. So that's the idea, again, of modeling furnitures and basically taking those two sides. The human is really free to create whatever he or she likes just by dragging parts from a library of parts, positioning them, and then the computer behind the scene knows what connectors to put, how to actually create it, run some experiments on whether it's sturdy and whether it's stable and all those things. And if it's not, basically alarm the user. And once it's finished, you can then just create it based on the set of parts that you get. Let me move to a different domain. In this case, it's video editing. In video editing, it's yet another domain where it's really more an expert domain. So I don't know how many of you, some of you probably, but not all, did actual video editing, right? So in order to create a movie, even a short movie, even a presentation, you first have to go out and capture some footage, and then you use that footage in a program which is as complex as I've shown you before about the three-dimensional modeling. But in this case, you get the footage, you place them in what is called the timeline, and in that timeline you move the different footage or the different shots to different places, you cut, you change them, you have various channels. If you want to combine various things, you need multiple channels, you can add sound and so on and so forth. Now, this is an amazing tool. Actually, it's made video processing much more common, I would say, but still you need to know this tool. You need to understand how to do video editing, but it's not for everyone. Now, when you think about it, sometimes you really want to tell a story or something about, or create a simple movie. I'm not talking about a full feature movie, I'm talking about simple videos. And anyone should be able to do it with the computer. So something that anyone can do is really text editing, right? So when you think about editing, usually people think about text editing. So anyone can use, Word or other or Google or whatever you have to edit some piece of text, change the, the positions of things and so on. So the idea of this tool is really to base yourself on text editing and create video editing. So what you do is you edit the text as a human, and the computer basically creates the video for you based on editing the text. So here's an example. I went to the safari in Africa, and I have many footage of giraffes and lions and so on. And I write something about the giraffes. And in a sense, what happens behind the scene, the computer creates a video that you can then later on have some a voiceover of what you wrote that actually creates this movie. So I gave an example of safari. This is an example of a chemistry class. Here's an example of a trip to London. And some of these videos could be your own videos, and other videos could be, in fact, taken from the internet, which is what we did here. So you have just a bunch of videos that you download from the internet about London, and you can create it. I muted the sound, but here it's also a song. So you can also take a song and create a video for this song based on the lyrics of this song. So this is about dogs. So how are we doing this? So first of all, when we look at the text, we separate the text to what we call, this is something else, but basically we divide the text to segments. And a segment could be more or less a sentence, but it could be more than a sentence or half a sentence. But let's assume that each sentence is a segment. And what we do, in order to automatically create a video, we need to link the content of the sentence to the content of the visuals, in our case, which is videos. So how do we do that? We were using, in fact, an NLP application, which basically creates or can understand what's written, what is the main subject of this textual segment. And then we were using a connection between the text and the images, the videos that I had, in order to link, to create those links. The next thing is, obviously, we create a voiceover, again, for example, by text to speech, or you can basically take it yourself. And then the only thing that we need to solve is how to time the different segments themselves. So that is the idea. So let's talk about the visual content. So how do we link between visual content and textual content? So first of all, as I told you, we gather, so obviously your text needs to be connected somehow to your visual, right? So you can't just use any visual. So you assume that the text that you write will be connected to the visuals that you have. In this case, this was a trip to London, so we gathered, just downloaded from the internet, London videos. And here's some videos about gardening, and again, we just gathered from the internet videos about gardening. So when we want to write something about gardening, we would probably use this library. When we want to discuss London, we'll use the other library. But the idea is to map both the visuals and the text to a joint space where you can connect between them. So you have a search space where you can query using text, and the results will be visual, will be parts of the visual. Now, how do you do that? There are many ways, in fact, today to do that. One of them is exactly the one that was based, DALL-E was based on. The application I showed you at the beginning. You remember, this is writing text, and then the computer creates an image of, a bowl of soup that looks like a monster, right? So, in fact, they were using a space that's called CLIP, and this is a space where you map both visuals and textual objects semantically into this space, and then you can find connections between these types of things. And so we weren't using CLIP because this work was done 2 years ago. It wasn't available then, but we're using another. It's called VSE, Visual Semantic Embedding. So basically, we're using another space, but the idea is the same. And even today, they're much better. So what we could do then, today we can even do better. So in fact, what you do is you, as I said, separate the text into segments, and then in each segment, you search for visual content in your repository, and that visual content can be now candidates for this specific segment. But remember that I can have many, many candidates, and I want to create a nice movie. And creating a movie is not just, getting videos from the internet and attaching them one after the other, because there are many different constraints that actually create a movie which is a plausible movie, a coherent movie, a movie which is nice to watch. So this problem is solved by basically the part that's called shot assembly. So here's some examples of the shot that we assembled. If you have a sentence that says the giraffe is the world's tallest animal, you can see many shots. These are just obviously one frame, but behind this there's a full video shot. So you have shots of giraffes. But when you talk about it has a brown mane on the neck, you can see that, in fact, the semantic embedding gives me more specifically, the neck of the giraffe and not just a general giraffe. So this actually is done by the visual semantic embedding, and you can find, more specific clips to attach to the specific segment. Now, once you have for each segment a bunch of clips, then you need to choose which one to actually create, and then connect them in a sense to create a movie. So you start with this clip, you move to that clip, and so on. So this is a general optimization problem. We were solving it using dynamic programming. If any of you know about this algorithm, it's a rather efficient algorithm that uses some constraints. I'm going to tell you a little bit about the constraints themselves, but in fact, it's an optimization problem. So we solve an energy minimization problem. And we have 3 types of terms in this energy minimization problem. The first one is terms that relate to the actual shot. So we would like to favor stable shots and more clear shots and things like that. I'm going to have some examples. Another one is the cut. So as I told you, if you just put two shots one after the other randomly, you won't get a coherent movie. I'm going to give just one example. If the camera is moving from right to left, and then in the next shot it's moving from left to right, this is called a jump cut. So basically when you watch a movie, it doesn't look nice. So what you do is usually you can try to look at the camera movement in each shot and try to basically connect them coherently throughout the movie. So this is another term that we were using there. So we have various terms. Here are some examples. So as I told you, we want more brightened shots and not oversaturated or undersaturated shots. We want stable shots and not jumpy shots. So we measure these types of things. And as I told you, if we're going up, we don't want to go up and then immediately down, because that actually, again, violates some cinematography rules. So connecting all these together and solving this problem, we can then create a movie. On top of that, so this is the shot optimization. I'm going to skip this. And on top of that, we have a user interface. And the user interface, in fact, is, as I told you, the user only writes text. It doesn't actually edit the movie. And then the movie is created whenever the user, let's see if it works, yeah. So in this example, and it's a little long, so maybe we'll skip some of it, but you write even one sentence, immediately the search is going on, and you get some footage that's related to this specific sentence. You write some more sentences, and then you get some more shots, and the color of the shots is really the main subject of this specific sentence or this specific segment. And obviously, when you start filling in the sentences, you can also add and you edit a little bit more. You make it a little bit more longer. You'll need more shots, so you'll see that more candidates are coming in. And then again, basically, when you press render there, you will see the movie that's created based on the dynamic program. You can copy and paste whole parts, and then it runs in the background and creates various segments. And again, each of those segments has a specific subject, and then you extract from the repository various shots. And when you press render, again, it solves the optimization problem and creates a movie. You want to add something in the middle, you can then edit and add something in the middle and change. You can also you'll see in a minute, you want to change the main subject of a sentence, you can grab a subject from the subjects that you predefine and then drag them on into the text. You can change the order of the text, and that would change obviously the order of the shots. You can split the segments and so on. But remember, again, the nice thing to think about is that you're always editing text, something which is very simple. Anyone can do it, and the movie is automatically created. You do have some, way to affect the text, the actual shots, because you can, in fact, in a minute, I think you'll see an example where you can delete some of the shots that you don't like, and so basically that replaces the shots, and you can insert and divide the segments or merge segments together and so on. So I think here's an example. This is before merge and after merge. Anyway, you get the idea, I think. Okay. Yeah, there's some more delicate things that you could do, which is called timing. So you can change the timing of the cut between the shots, but again, only working on the text. That was the base idea.
Can it also do the other way around?
What? Take a movie and convert it to text? Well, you could do it, not in this, but this is something else. But hold that questions. Maybe I'm going to get to that in the end. I'm trying to move forward. Okay, so the human writes the narrative, obviously, orders the sentence and build the actual story, obviously. But the machine gathers the clips, matches the text, finds the cutting position, and composes the whole video. And then basically just by writing text, you can create a video. Obviously, if you have footage, right? So if you don't have the right footage, you won't be able to create. But that's the idea of this write a video paper and work. Okay, so I've shown you 3 examples of various tools that combine AI and humans, right? So human in the loop is always the case. So it's not just an agent that can create, something individually, although maybe it's possible. I actually think that I would like to promote more the synergy, as I told you, between humans and computers, and take out all the tedious and computational heavy and physics and expertise part from the human and let the machine do that. And basically free the human to be more creative, create furnitures as you want, edit images, create videos, and so on. So you actually, using those tools, you can free the human to concentrate on the creativity. You actually have to have fast feedback, and many of the examples I've shown you, that was the key point. Especially in pre-sweep, you immediately see the part that you're creating, and you immediately see the results of your text editing in the movie. Because otherwise, it won't be a tool, right? Otherwise, if you have to wait for 10 minutes to something to that, sorry, it won't be interactive. But in a sense, in many cases, and that's maybe a little bit related to what you're working on, you have to trust the tool, because in a sense, you're giving away a lot of freedom. You're saying, okay, the tool will create the movie for me. I'm just going to give you high-level, directives, and the movie would be created. Or I'm just going to, gather a bunch of parts, and then the tool will be responsible for whether it's sturdy, whether it's stable, and so on and so forth. So, in a sense, you allow some independent decisions for the tool. But that frees you to be more creative, but you have to trust the tool in a sense. So this is another interesting thing. Okay, so thanks a lot, and I'll be happy to take any questions if you have, but I don't know if you want to talk first.
We'll jump in.
Exactly. So now it's a role of the discussant to be, and thank you.
Great.
I don't know if we can sit here, the mic will pick us up, or if we need to move a little bit that side.
Sure.
But thanks, Professor Shamir, for this very interesting discussion. Lots of very rich projects, very interesting. I think it's interesting because it also draws parallels to my own work, because before being in data and artificial intelligence at NG, which is an energy company, my prior life was in music technology. So I spent 10 years at MIT and elsewhere doing work on AI applied to music and creativity as well. So I think I'll make some links with that part of the work, as well as some links with the energy sector and the industrial sector, maybe if we can do that. But first, maybe a thought on the furniture making. I'm sure there's a big, well-known box furniture company that would be interested in this kind of tool. Did you ever consider?
Well, of course, I did consider, but again, it depends. So the funny thing is that I showed this work maybe 5 years ago at NASA, as I told you, and they were actually interested in creating a tool for small satellites that they send. Usually, they have they have the big missions, but whenever they send a big satellite, there's some space in the spaceship. And so basically they design these small types of satellites that create various experiments in space and so on. And designing those satellites is really highly constrained. And in fact, I was working a little bit with them to create something that would be able to be similar to this. So basically the designer or the scientist, in a sense, inserts all the different components that he or she needs in the satellite, and then the tool basically orders them and finds correct connections and so on to actually place it. So that was the most applicative that we went.
Right.
But We weren't approached by IKEA yet, but we're still waiting. So
Yeah, absolutely. So the project you worked on, transforming text into video editing, is interesting because I worked on a project that I called designing sound with everyday words. And that was based on the observation that musicians describe sounds when they talk about, in a band playing music, make it sound brighter or make the bass warmer. It's shiny. It's you assign words that come from different sensory inputs to your auditory perception.
Nice.
So the idea was, can we look at what's the mapping between these words and the sounds, and then can we design a tool that uses these words to then design and synthesize new types of sounds. And one question I had at the time when I designed that was, is it a universal concept? Do every musician, regardless of their background, their musical style, their instrument, describe it in the same way? Did you think about that, or did you consider that in your work?
Well, in a certain extent, yes. But what you're talking about is really an interesting problem. Of course, not just in music, but in other domains as well. When you think about editing of media, even images, or there is a work, for example, that tries to describe fonts in a descriptive way. So make the font funnier, make the font happier, and so on. And they were using machine learning to map these declarative idioms into some real space, and then from that space find the best font. So in fact, I think that this is, the two questions that you were asking. First of all, whether any person or most person, let's say most people, will actually describe the same thing when they say a happy font. That's the first question you need to ask. And if that's true, then probably yes, you can then create a semantic space where you map those declarative things into more specific constraints or things that define your actual object, whatever it be. It could be a furniture, it could be a font, or it could be a music piece. So in fact, now in my experience, I think in most cases you do find things, cross-cultural things, right? Obviously not everything, but in many times when you think about jumpy or happy or colorful or sad, so these things are universal in a sense. And in fact, you can find amazing things, like if an image produces some feeling, it probably would produce the same feeling across cultures. So
yeah, that's my finding as well. I think the idea of culture in AI is quite important, and something that I studied in my research during my PhD as well. So one of the projects I worked on was based on a problem I personally have, because I moved around different places and I was a musician myself, and I had collaborators in different places, and I wanted to continue playing music with them while I was away. And if you want to jam with someone, you can't really use Teams or Skype or things like that because of the latency. So how do you design a system that can help reduce latency and synchronize streams that are maybe half a second delayed from each other? So I used machine learning techniques and I developed a system. And I found out after developing that system that most of the technology developed for music, but it can be applicable to any kind of art forms, is the fact that the designers themselves introduce a bias, which is based on their own understanding of their culture. Very often it's Western culture, Western music, because that's what's more prevalent. In the realm of music, we all know MIDI, which is a standard technology to quantize and to represent notes, and those are based on a fixed pitch without all the nuances and tonal nuances and rhythmic nuances that you could have in Western music, in non-Western music like Indian music, Chinese music, Middle Eastern, etc. I'm curious to understand in the visual sector, what's maybe the parallel, how do you think about the difference between individuals, who have their own specificities, and you can say that a director who does a montage for a video is you can sense a personal individual touch, on one spectrum, on one end of the spectrum. At the other end, you have very generic things that everybody would do because they're what cinematographers would do in general. And in between, you have this idea of culture in some sense that's sort of a meta model of a group of individuals that share some commonalities.
Right. Well, you know, style, I think, and you're touching upon a little bit style of individuals or style of cultures and so on. Is a different thing that I'm researching in terms of the, you know, for drawing and sketches and things like that. So I touched upon that, but mostly for, you know, individuals and not cultural things. It's hard for me to say, actually, if there's an analogy in the visual world of, I mean, okay, one thing that I can comment on is that I came back from a conference here in France. It's called Eurographics, and we were presenting there a work that tries to segment artistic images, so paintings. And in fact, it was based on neural networks that learn specific styles. So, and we were using various styles, Western styles mostly. But what the interesting thing, which touches upon what you say, when we tested it not just on Western paintings, but also on Chinese and Japanese and so on. And in fact, it worked quite well also for those types of styles. So in a sense, I think maybe the arrangement of individual things in an art form is something that is different in different cultures. But if you have a base representation, you can in fact use it for various cultural and various things. So and personally, as I said, I never actually investigated the differences in cultures. But I certainly agree that it's important. I mean, I don't know if you think of you know, furniture modeling. Do you think that the Indian furniture is different than I don't know, American furniture? Could be. But it's certainly an interesting.
Like it's very Nordic furniture and it has a particular style.
Oh,
right?
sure. So in terms of style, again, so style, yes, is something that I did work on, but again, trying not to, you know, connect it to culture. I think that's a little bit of also danger to tread upon. But certainly you have styles in images, you have styles in paintings, you have style in furniture, and this is again something which is difficult to actually you know, quantify. So. But we're moving in that direction, I think. So.
I think one way, it's very interesting. I use the concept of cultural plugins to you know, specify certain specific knowledge that you know would be specific to certain types of styles of music. And I use you mentioned the idea of energy minimization.
Yes.
I use the concept of entropy based on the fact that, for example, there is as much entropy in Western music, but it's just distributed differently in harmonic complexity versus melodic complexity and less harmonies in Indian music, for example. But the level of entropy would be similar, just distributed differently. But anyway, to switch gears a little bit, you talked a lot about semantics as well,
Yes.
Which is a very interesting topic because it touches upon a variety of fields. And even in industrial sectors, it's something that we now talk about when we talk about data and AI. What was the sort of, how do you generate the semantics to start with? Is it manual labeling? Is it recognition of images? How do you build your set?
Yeah, so I think, as you said, semantics is really a very popular thing today. I mean, and if I think about my own research, in fact, that was the leading thing in all the works that I did, because my interest is really about semantics. And when I talk about semantic, it's really high-level semantics. So even when you had low-level tools for image processing and for video processing and the other, I don't know, for three-dimensional objects, we were always trying to push towards more semantic understanding and more semantic utilization. So as you've seen, I think, you know, for example, dragging whole parts of furniture is actually modeling in a high-level semantic. So you don't really have to cut your shelf. You just drag a shelf, right? You don't have to create a wheel. You just drag a wheel, and so on. So in a sense, semantics is really at the core of what I think everyone is doing even today in vision and in NLP and so on. I think what the and as I said at the beginning of my talk, I think that today, large companies like Google and Facebook and other, they have data in the trillions, right? So they have a lot of data, and what they're trying to do is basically based on that, create some understanding of the world as it is seen from, let's say, all the Twitter, sentences, or all the images you have on Facebook or on the internet and so on. And they're doing quite well. I mean, so one of the things I was mentioning here is this space clip, which is both visual and textual. So you can think of it as a big machine that takes all the text and images that are linked on the internet and tries to learn from that the connection between text and image. So it's not necessarily manual editing for a specific task, but it's trying to build a general space where anyone can use it for various things. So, and our example is not different. There are many, many works today that are based on clip, that are based on something else that's called style gun. And so in a sense, machine learning and AI today, they're trying to do exactly that. So build semantic spaces of not just visual content, not just textual content, but something which is more high level or more combining. And hopefully these things would still remain in the public domain, because otherwise we're in trouble. So this is one of the things that maybe the messages that should be described, that these huge companies, they have huge amount of cash, they have huge amounts of resources, computing resource, they can create those spaces. And when you think about universities, even the largest universities and the largest labs cannot compete in this case. And so one of the important things when you think about industry is that if they do build these types of semantic spaces, they should basically provide it to the public to create various things on top of it.
Yeah.
Now, if you think about specific projects in my lab or in other labs, it's always, the simplest way is to, as you said, manually label. So for example, segmentation, you manually segment images and so on, and you create the data set, but it's not scalable, right? And it's very expensive and it's time consuming and so on. So many works today try to move towards what is called unsupervised learning. And one of the works, and some of the works that I'm working on, is called domain adaptation. And basically, it takes some data that you have in one domain and tries to use that data in order to learn on a different domain. So, there are many, many works today that try not to rely on manual segmentation, on manual annotation, on manual tagging, and so on. And I think the whole research community is moving in that direction. So there's a plethora of things that you can use.
That's interesting because a lot of people now, whether researchers, students, industry, use pre-trained models.
Yes.
Because things like GPT-3 is so computationally intensive and expensive. You need a lot of data to train. That not everybody can do it, both in terms of the data available needed to be trained and the computational resources to train the models. So all these foundational models, like Google calls them, I think are critical to new applications. But I think it's interesting now, if I put my NG hat in the energy sector, in the industrial sector, we don't have as much data as big tech, right? We have industrial assets that provide some amount of data. And the approach we tried was, supervised learning with small amounts of labeled data of when, if we do predictive maintenance, if something stops working. But those events happen so rarely that the models don't work. And then we moved to unsupervised learning, and then adopted a hybrid approach where it's supervised learning, but the rules are based on business knowledge and expert knowledge rather than predefined labels. And that seems to work really well. So it's it's not the latest deep learning models that we use. It's simple regressions, things like that, based on a combination of the data available that's very specific to a particular use case, the expertise and the business knowledge of people who've been working in the field and know the thermodynamics of how a power plant works, for example, and the data scientists who work with these three ingredients to create simple models that do their job and just work. And semantics is really important in that field as well, because you need all these models to be able to talk to each other. So there's an ontology that we apply to the data models that we have on equipment in order for an equipment that's built by certain manufacturers to be able to talk to another. And this whole field of ontology in the industrial sector is something that's really picking up.
Yeah. So I have two things to say about it. One is that I certainly agree. I mean, people are drawn to the flashy things, right? So they want to use neural networks, deep learning, and so on. But you have to remember that machine learning has a lot of tools, not just deep learning, not just neural networks, and they're working very well, also in the industry sector, but also in for research. So you don't have to jump and go all the way to neural networks when you have sometimes simple problems. And also, as you mentioned, second thing is that when you need a lot of data, then many of those big models won't work. And then in a sense, you have to combine and create hybrid models, just as you were saying. So I totally agree that this is probably the way to go if you don't have a lot of data. But the second thing I wanted to say is that you were saying that you don't have huge data, but one of the reasons is that, in a sense, companies are only now understanding that they need to monitor, they need to store the data, they need to collect the data. So in fact, many companies can have huge amounts of data. I'm sure that you can have much data only if you store it, only if you monitor it, only if you save it. And so I think a good message would be to start saving data, because data is extremely important for many things. Right?
Yeah.
So
yeah, it's a bit of a caricature when I describe, but we started the centralizing effort, which is starting to pay off now because we can really leverage the data available. Absolutely. So I'm sure there are questions from the audience. We can maybe pick up a few questions here.
Yeah.
So thanks for the excellent speeches and discussion. I would like to bring now the focus on the business, the company. So when we adopt this solution, because you showed the idea for product innovation in some way, so Cartel applied something similar to project the smart chair, so to put together the complexity of different variables to have a new product. So right. At the end, the company can have a new product. You showed also the application of AI in music, so in the processes, the optimization,
yes.
It can be applied to any other processes because I can optimize the process, similar to what other companies also in the oil and gas are doing, and to optimize also the value chain. So the question is, it's open, if there is a way to measure, do you think that using these tools, AI applied to processes in the companies, could leverage creativity, or what we call organizational creativity or business creativity? And if yes, how we can measure it? It's really an open question, open reflection.
Maybe start and then click on it.
So, first of all, I have to confess, anything that someone asks me, do you think that AI can? My total question is always yes, really. I mean, of course, it will take time, it will take effort, but in a sense, I really know that AI is going to advance, and we're going to, in the end, have real AI. But maybe 100 years from now, maybe 50 years from now. But in a sense, I really believe that we can solve problems using AI. And I think the theme that I was trying to make here is really, you have to think of AI not as an agent that will walk around, but more as an enabler for humans. And in a sense, I totally think that if you insert enough intelligence to your tool, then it can, in fact, enable more creativity, because then when in many complex processes, right? So I was describing design processes, right? And you're describing maybe business processes. But they're complex, right? Because you have many parameters and you have many constraints that you have to think about. But once you lower the complexity, because you offload this complexity to some tool or to some intelligent thing, you are free to think about things in a high level or more semantic things, or out of the box, like everyone likes to say. So in a sense, I actually believe that these types of tools and these types of things can assist in any domain, as long as you build them correctly. Because one of the points I was trying to make in the end is that you have to trust them. And in order to trust them, you have to make sure that you're designing them correctly, right? Because if you're making some errors, so, if it's designing a chair, the worst that can happen is that you fall. If you design something that relates to medical devices, then it's more dangerous. You really have to trust them. So as long as you think and you know that, if you design it correctly, I think certainly it basically, just because it lowers the complexity for humans, and the humans don't have to think about all the small details, and basically it frees their mind in a sense.
You put a second step in my question, then I leave. So, which is the role of a business school or a school that has to form the manager working in this environment? It's a matter of learning new work, new jobs, or learning how to work with, because you are from computer science and you are talking to social scientists, and you are perfectly able to understand the implication for us of this. So this means that there is a synergy. We are looking at the same problem from two different angles, and maybe it's a matter of languages that have to be aligned, or which suggestion? You are part of the scientific committee also of the high school, so this feels like it's super important.
Yes, so in a sense, I think that, well, you're touching upon a broader subject, which is basically, I believe that today in all education, not just in business education, you have to be exposed to these types of technologies in order to understand them. Right? And this is for the two extremes. On the one hand, you need to not be afraid of them. So basically, people think about, or really, but also be critical about them. Because as I was saying, when people look at DALI and they're sure that that's it. It's an intelligent thing that can make whatever you want, but obviously not. It's just a program. It's just a simple tool, and it does something very specific. And so you have to first of all know the limitation. But on the other hand, that's the other side. You have to understand what they are capable of. So what you can think about that they would do for you, and then you can advance your business, or you can advance or create new businesses, or so all these things, the capabilities on one side and the limitations on the other side. This is something that I think anyone needs to understand. And so exposing, I think, even business students to these types of technology and explaining them without a lot of hype, without a lot of neural networks. It sounds like, it's in a sense, as you were saying, it's all optimization. In the end, everything is optimization problems and solving optimization. One way or another, it's optimization. So when you think about that, you say, oh, okay, so it's not really an entity that's in there. It's just an algorithm. But then you say, oh, but it's a good algorithm, so let me utilize it to do something. So I certainly think that it should be part of the curriculum and part of exposing students right from the beginning. If you ask me, even in school, right, you have to start explaining what programs are, what is computers, and so on. But again, this is touching upon something which is much broader. I don't know if you have something to answer.
So you had a very interesting question, and so on the industry side, I think, so we have to keep in mind that there are different types of AI, and I'm not just talking about the technology, but there's AI to replace human skills that does what humans do, and there's AI that does things that humans can't do, right? And typically the artificial intelligence works well on things that are tough for humans, and vice versa. That things that humans do well are tough for machines to do. But in the industry sector, so one way to scale the capabilities of humans is to introduce AI in processes that exist, like, for example, recruiting. And there are counterexamples to that, because we all know of examples of Amazon trying that, and the biases that came through the implementation of AIs in selecting resumes, etc. So I think there is a very strong importance of people understanding, like you mentioned, the limitations of algorithms, and there comes into question, the black box version of AI, deep learning algorithms that sometimes are really difficult to explain, versus things that are simpler and that are more white box types of things that I was mentioning that we use at NG, for example, because they're based on business rules, and they have the faculty to be more explainable, and we can take decisions based on them, and we understand why. And in certain sectors, it becomes critical because, for example, in finance or in health, you want the doctor wants to be able to explain to their patient why is it that they think that the symptoms will leads to this diagnosis, etc., or why this loan was approved or not approved. What are so there's some regulations around that. There's some ethical considerations around that lead to certain choices of algorithms. One type versus another, and therefore the people who make the decisions to improve the processes, use AI in their industry, need to understand not just the big picture, but also I think it's useful for them to put their hands into the technology behind it, understand a little bit the math behind it. I think that's part of the training that needs to be done. I think it's the nuances are very important in this kind of new technologies, and I think that comes from understanding, trying to build yourself, even if it's just an overview. But I think lessons in coding and things like that are important for students who are going to use these tools in industry.
Thanks.
Hi. First, I would like to thank you for this presentation. I would like to come back to the first question of Margarita about creativity. The software you show us are very useful, especially for people who are not expert on the matter. But does it really improve creativity? I mean, first, the user is limited by what is proposed, what is possible with the software. And second, the user will be tempted to be passive and wait for the suggestion of the software, and therefore, do you think that it really improves creativity, or on the contrary, could it inhibit the creativity, creating a dependency of the user to the software?
So I have a few comments to it. First of all, let me start with a simple one. Just to talk about the tools that we were showing, in fact, if the user does not do anything, nothing happens. So in fact, what you were saying, that the user will wait for the tool to do something, that's exactly, you're correct. And that's exactly what we were trying to prevent. So the user needs to be engaged and needs to do something in order, both in the furniture design and in the video design and in the 3D modeling. If the user doesn't do anything, nothing happens. So in fact, you always have to be, doing something in order for the tool to work. So it's a good point, but in fact, we were actually following that in our design of the tools. The second thing that you were asking is whether, again, more generally, how can you measure if it enhances creativity or reduces creativity? That's a big question. How do you actually measure these types of things? But having said that, I have to comment something that I've learned, and I know from artists and from designers and from other people. Many times, once you constrain yourself, you are actually enhancing creativity. If you say anything goes, and you have a clean slate, you just want to design a house, okay? Any house, in any lot. Well, then you're lost in a sense. But if you say, okay, you have this type of lot and you cannot design only for 3 stories and it has to be this size and so on, then people start to be creative, and because they have some constraints. So in fact, as opposed to what you're saying, I think that when you put constraints, you actually help creativity. That's my impression again. So we didn't, of course, measure anything. But in many cases, I think that, in fact, exactly this, those tools, once you constrain them, so, you know, because again, if you ask someone, okay, make a movie, okay, what movie and what time, use some footage, or what footage you do. But if you have a library of footage and you're making a movie out of this, in this subject, then you start, you know, jump-starting the process of the creativeness of creating something. And I think that's important. And I think if you know, totally free someone, it will be much more difficult to be creative. And again, this is not just my own view. I think I learned that from many artists and designers and so on. So in that sense, I believe, but again, this is really just belief, and we never measured it. I believe that these tools will actually enhance creativity. But
thank you.
it's a big question.
Yeah, sorry. I think that we're talking, just going back to you, and you confirm that we're talking about the creative process, not the creativity. The creative process with this tool is completely enhanced because you're doing literally not overthinking, but the creativity then based on the culture, based on the library, based on everything that you feed. Yes, it will be limited in a sense, but we're talking about the creativity. You need image, you need very precise to deliver emotion, colors, and so on. But the creative process with this is completely awesome for experts.
You still think they are experts?
Well, I mean, an artist is an expert with his own intuition. How do we measure the expertise? I think that for students, coming back to your question, this is my personal opinion, this is great. They learn that what they can do with artificial intelligence, with their own human capacity, ability, and this is a creative process. If I'm a designer, if I'm an artist with my own intuition, background, then this is a really good tool for me because I know I will be limited in a sense, and then I will add my own expertise. So I believe this is more for expert in that sense. My question was just my opinion.
Sure.
My question is more, can we combine the two, the video and the, the two tools that you have shown? So I want text editing, and then I want to add 3D in this, so combining the different tools.
So adding 3D to a movie? That's
Yes.
But it's a different problem. I mean, it's not, the 3D editing is really creating an object, right? But once you have the object, how to insert it into a movie, that's, people have worked on that. So it's not, obviously not in this tool, and not, we are a research lab, so we are not really creating,
I'm just thinking that for the new jobs in the future,
yes.
there's a big part of the job will be to design universe. We're talking a lot about Metaverse, but we will be, designing a completely virtual world using video, using existing 3D,
Right.
and these tools will be actually for designer absolutely amazing.
Yeah.
Just moving forward in these new jobs. So yes, combining everything with real world 3D and videos with with copyrights and so on. I think it's combining the two might be very, very interesting.
So sure, I agree with you. Only two things. One is that you need to have much more in order to actually be able to design everything. I think it touches upon what you were asking before, right? So if you take a video and you create a story out of the video, understanding the story, which is another topic that I'm actually working on to understand videos, understand stories. And there are many powerful tools today to understand images, right? So you can understand a video, it relates to temporal domain, and it relates to causality, it remains, so it's more difficult. and they're not very good tools today to do that. But what you're saying is basically, yeah, why not, use everything? But sure, I totally agree, but it's very, very complex. I mean, you have to have, right? So let's just talk about what you suggested, taking a three-dimensional object and inserting it into a video so that the lighting would be correct and the size would be correct and everything would look, it's not as simple. People are working on it, but even this small problem, just this, is difficult today. But as I said before, you will have it. Maybe not us, but in the future, people will have it for sure.
Well, it's augmented reality.
Yes.
Yeah, but you have to design the augmented reality. Sure. You have to design the reality to be.
No, we can put your object into a movie.
Yeah,
we can do that. That's augmented reality.
But you need eye-opens. Yes.
Yes, so I have first an invitation for people on the chat to ask questions to, so those who are connected not to be excluded. And the second thing is, well, actually, if I'm looking at the example with the videos, it is definitely driven by the text.
Yes.
And in that sense, we are talking here about the specific process and the specific creativity process, and maybe specific skills related to how to script and what particular words to use, explanation, etc. So it resembles in a way with developing programming, even if it's not programming, but it's specific skills, as was the case with programming. For instance, and my question now, so it's just an observation, and my question is, in this text, do we need to be very detailed, explicit in the instructions and scripting, or is it possible, for instance, to detect the tone, the sentiment, or some elements that are not particularly visible at the first stage?
So first, I have to say that I actually don't agree that the text that you put there doesn't contain any direction. It's just whatever you write. So you can write a story, and then the tool, based on natural language processing, extract information. We were extracting just subject or main subjects or things like that. But certainly you can use sentiment. I mean, basically you can use sentiment analysis, and then if you see that the sentences are, I don't know, sad or happy, then you can choose video that will be related to that specific sentiment. So this can be done for sure. I mean,
I didn't want to say that you need skills in programming. Of course, it's language, but writing a script or writing a text requires some specific skills.
So again, writing a script, you're right. But this is not even a script. This is just text. You write whatever you want. So maybe because of the time, I didn't show you actual examples, but the text is really simple text to write. So I visited London, it was very fun, we were going into Hyde Park, and we saw some ducks. And so really just simple text. You don't need to add any directives or nothing. So basically this is all done by the background program. So in that sense, that's the idea of really making it more accessible to anyone. Not to experts.
It's a democratization of it.
Yes, exactly. I'm often using exactly this democratization of 3D modeling, of video editing, so these types of things that anyone can in fact do it. Because the expert is the AI. The machine is the expert, and I'm just a creative person that wants to do that. So at least this is what we're trying to do.
Maybe to add to the creativity discussion, I completely agree with the fact that constraints, enhance creativity. Absolutely. And I think, based on some of the questions around the tool, I think it's important to keep in mind what you're doing. Why did you develop the tool? Who's the user? And what are they trying to do? Because most likely a user for this type of technology would care about the end goal of, creating a video to accompany something, but they don't have the the creative control over details that an expert might have if they're making a movie, or maybe it's a different tool based on that. So I think the idea of affordances that a tool can provide, and how you use that to your advantage, and how you go to the limits, and maybe you want to, you understand the tool well enough that you can tweak and go to edge cases that, do something unexpected sometimes. And those are the things that creative people might use, up to the extent that they build their own tools. A lot of creators now build their own AI, build their technology, generate art. Maybe it's a one-time tool that's used to generate art, and now with NFTs, digital art is becoming something of a real nature, right? And it's being sold in auctions and things like that. So
good. So we have still 4 minutes. There is one question in the conversation, let's say from Anna. Thank you for the great talk. Can you speak a little bit about how you come up with the domain-specific criteria? For example, cuts, brightness, saturation, stability for video editing. How do you know when you have the correct set?
Oh, so these are 2 different questions. So when we ask about how do we know the criteria, this goes back to what you were saying. It's experts. So basically, expert knowledge. We're trying to hone on that and insert that into the intelligence of the program. So in the video, for example, stability and brightness and all these things are common things that people are measuring when they say this is a good movie or this is a bad movie, right? So in that sense, this is really expert knowledge that we're trying to add in. But then, what was the last part?
Is how do you know when you have the correct set?
Oh, okay. So yeah, that's a good question, because then you say, okay, you have one constraint and another constraint and another term in your optimization and another term, and basically when is enough, right? I guess in most cases it's really trial and error. So there is no way, in a sense, to prove that you covered everything and now you're done. And this is basically the optimization for the best movie that can be done. But the other side is that because of that, you can also add some knobs and tools and weights for the different, so you can add style. So maybe in fact you don't care about jumpiness in your movie. Maybe you want jumpiness in the movie because it's a movie music video, for example. So it's good to have jumpiness. So then you can lower this term and raise other terms. So it gives you some adjustability for these different terms. And but it's a good question. I mean, whether maybe we forgot something that is crucial, and but usually we see that in most cases for 3D modeling, for creation of videos, there are some set rules that you can use that cover, I would say, most of the things. It's not that. So a new domain, I don't know. In music, for example, I don't know what to do.
Then I think the question of validation is very difficult, because you could make thousands, millions of movies that respond to the initial input. You can maybe say it's good or bad based on objective criteria, but on a good movie, can you say that one is best and the best are better than another because it's so multidimensional? And it's true in the industry. If we look at validation, when we talk about doing a predictive maintenance engine that predicts when a piece of equipment is going to fail, how do you validate that it's true? Because you replace that equipment before it fails. So there's no real objective validation. You rely on experts or critics in the creative domain to validate.
I give voice. There is in SKEMA, there are some colleagues focused on studying how augmented reality, virtual reality, and Albert Valerio can be used inside the education process, inside the class, maybe to improve the experience of the student, to make maybe the student more creative or to learn better. Which is your vision about this? So it's just a fashion to use these tools to make more engagement among the student, or maybe they can be used in the right way to stimulate creativity?
Well, for me, the technology is always a tool, and I think we need to understand. So both, I think it can help do things. One is help solve problems. So you have a use case where you're trying to solve something that you understand, or create new opportunities, and that's something more perspective where you don't really know where you're going. So in the case of the metaverse and augmented reality, etc., I think we're more in the prospective side. It's a question I've been asked this past week. How can metaverse help in the energy sector? I have no idea. We're going to do to see how things develop. It's a tool for things that can be done. Is it something that's useful for people? On campus in classrooms, is it useful for people on the field in industries, etc. I don't have an answer today.
I will be optimistic again. I will say, sure, it is. But because
I can do everything.
in the end, not today. In the end, it won't be able to do anything. But in terms of the virtual reality, I'm sure there are many cases where you can enhance your knowledge and your experience when you are actually on site. Right? I mean, in the energy sector, maybe you have dangerous sites and you need someone to know the site. So you cannot drive in there, but you can virtually place them in the scene, and then they can walk around and understand where everything is. And so I'm sure there are many cases where virtual reality can assist in many sectors, and also in education. And even for the fun of it. I mean, I think people would be more engaged, and we all know that when you are more engaged, you learn better. So even if you're more engaged because it's fun, yes, you can add that edge. But there are many, I'm sure, experts here, there are many scenarios where virtual reality could be used for education.
So great, the time is over, so we thank you greatly both of you for sharing your time, for coming here in SKEMA in Paris. Thanks a lot, and thanks for the people connected and the people in the room for attending this seminar. Thanks.
You're joining us?